to attempt dramatic stand-up.
This person
Attempt a dramatic stand-up. Attempt a dramatic
remains in motion.
stand-up.
The car is going at 20. He's going at 20
Dramatic stand.
when he jumps. He's not connected to the car. He's maintaining his horizontal motion. He's falling under the influence of gravity, but horizontal motion is independent of the vertical motion. So he's maintaining a constant speed. If you were the driver, you can speed up. He won't be able to keep up with that. You can slow down. He won't be able to keep up with that. You can change direction. He won't be able to keep up with that.
Stand-up. Dramatic stand-up.
If the car accelerates in the forward direction, because you won't be able to keep up with it, you will move backward relative to the car. If you put the brakes on as you're jumping up, this time as the car is slowing down, you're going to be moving forward relative to the car. If the car changes direction, you're going to keep on moving forward in the opposite direction of the acceleration of the car again. Do you notice that his body is always going to move in the opposite direction of the acceleration of the vehicle, despite the fact that he's not attached to the vehicle?
The first law of motion.
Could you tell us about that?
It states that an object at rest wants to stay at rest, and an object in motion wants to stay in motion. Property of matter by which it keeps its rest or speed. Okay, let's start with an object at rest. Have you ever seen somebody pull a tablecloth out from under a set of dishes, and the dishes didn't move?
I've never been able to do it, and I've broken a lot of very expensive dishes in some very expensive restaurants trying.
Well, the plates have to be heavy, and the tablecloth has to be pretty smooth, and you have to pull it really fast, but it can be done.
But what does that prove?
Well, the dishes are at rest, and they don't want to move. They would rather just sit on the table.
And so what's the motion part?
An object in motion wants to stay in motion. That's why we wear seatbelts in a car.
Oh, I get it. Wait a minute. No, I don't.
Well, if you're in a car...
Can I get a ride? I got to return my video I rented.
Sure. Anyway, if the car is in motion, then you and I are in motion.
There's the video, so you passed it.
If the car stops, you don't stop. You move forward. That's why we wear seatbelts, to stop us from flying forward.
Okay, guys, put your responses in the chat. All right, so I'm seeing a lot of B's. While B is a correct answer, one of the correct answers, that's not the only correct answer, right? All right, so I also see A. A and B, both of them are correct answers. Newton's got 3 laws. So to be precise, though, this is about the first law, right? This is the law of inertia. So that's what we were discussing. So the meteors in outer space keep on moving rather than slowing down and stopping. The physical idea that predict this is actually the law of inertia, right? All right, so those of you guys who pick A, give yourselves 5 points. Those of you guys who pick B, give yourselves 2 points. B is not wrong. It's just not the best answer. I think you guys will do better with this one. All right, so in the absence of an external force, what do we expect? So we expect a uniform motion, right? Straight line at a constant speed with no acceleration. So E is the best answer. So those of you guys who give yourselves 5 points. All right, so once again, so there's a half a second push against the spacecraft. The moment of separation, the astronaut is moving at a speed of 5 meters per second. So the question is, how fast is he moving about 10 seconds later? So he's going to retain that initial speed in the absence of an external force. So he should be moving on. He should keep moving on at the same speed, which is 5 meters per second. All right, so the best answer is E. All right, so it looks real fuzzy. It's kind of weird. All right, so it's chapter number 4. Newton's laws of motion. All right, so far we're looking at the first law. All right, so the first law is the inertia. It just means the tendency to retain initial motion. All right, so it's the tendency to retain initial motion. To retain initial motion. Motion means velocity. Velocity is a combination of speed and direction. All right, so this tendency is going to come about only in the absence of an external force. So the tendency to retain initial motion in the absence of an external force. All right, so let's say net external force. All right, so I'm going to put the emphasis on net external force. So only in the absence of a net external force, the object is going to get to retain its initial motion. So motion gets retained, which means that if the object is moving to begin with, it's going to keep on moving in a straight line at a constant speed. If the object is at rest, it's going to remain at rest. So tendency to retain initial motion, that's one interpretation. It's going to have a second interpretation. The second interpretation is going to say resistance to change in motion. All right, so that also means the resistance to change in motion. All right, so resistance to change in motion. All right, so it's got two interpretations. One of them is the tendency to retain initial motion. The second one is the resistance to change in motion. Tendency, resistance. Tendency to retain initial motion, resistance to change in motion. And this behavior exhibits itself only in the absence of a net external force. So two interpretations: the object at rest is going to want to remain at rest. The object in motion is going to want to remain in motion.
So how's that diet coming?
All right, so this is a Super Bowl commercial. Car accelerates in the forward direction, unstrapped objects will move backward. You put the brakes on, acceleration is backward. Unstrapped objects will move forward in the opposite direction. Nice Heimlich move. He's regretting that decision of saving his life. Speaking of commercials.
The Lexus GS400.
All right, this commercial is almost 20 years old. Today, the commercials are 0 to 60 within 4 seconds, 3 seconds, or so forth. Back then, they used to make smart commercials. What they were saying is the acceleration of this car is just so incredibly great that even your brain is not going to be able to keep up with it. Neither are your eyeballs. Now, that's a smart commercial.
Fast.
A few years later, they came up with even a better commercial.
The quick, remarkably agile Lexus GS. Use it as you see fit.
Acceleration of this car is simply so great, not even a fly is able to keep up with it.
And their
So the unstrapped objects inside vehicles,
ability to record
why do they keep moving in the opposite direction of the acceleration of the vehicle?
usable data was limited. Then the U.S. government mandated auto safety testing in 1966. And
A dummy the size of a 3-year-old in the front seat of a minivan was looking back at a 6-year-old in the back seat. Neither is belted in.
All right, so it's a crash testing at 40 miles per hour. So the vehicle is moving at 40, and everything inside, everything on the inside, everything inside the vehicle is still moving at 40 miles per hour.
At impact, both
So as the impact starts, the car is slowing down. And notice that the dummies are going to keep on moving at 40 miles per hour.
Both dummies
They're simply maintaining their initial motion. That's it. Inertia. Tendency to remain initial motion is the reason why unstrapped objects on the inside will keep on moving at the initial speed of the vehicle.
are launched
So they will go all the way up to the dashboard, and they will hit the dashboard at 40 miles per hour.
into the dashboard and then bounce
So what's pushing them in the direction of motion? Nothing. What's pushing them in the opposite direction of the acceleration of the car? Nothing. They're simply maintaining their initial motion.
off the windshield. 65% of
The car is moving at 40. Everything is moving at 40. The car is slowing down, and strapped objects will keep on moving at 40 miles per
children
hour
ages
in the opposite direction of the acceleration
4 to 8 who
because of inertia.
die in car accidents are unbelted. And watch this chilling scenario.
All right, so the objects will fall off.
Children riding unrestrained in the back of a pickup truck.
So the vehicle changes direction. The dummies keep on moving in a straight line at a constant speed in the direction of motion
It
as they're getting pulled down by gravity.
happens more often than you think.
All right, so inertia is,
And their ability to record
Riding unrestrained
I think this is one of those concepts that I ended up discovering on my own when I was 3 or 4. Remember, guys, in the cartoons, you can make this 90-degree turn on your tricycle. So down a hill, I used to try to make those turns, only to realize that it's impossible. You always spill over, and then you get bloodied a little bit. So I would try. I used to get so frustrated. You can't make those kind of turns in real
in
life
the back of a pickup truck.
using a tricycle
It happens
because you got inertia. So you got a tendency to go in a straight line
Not
at a constant speed.
in outer space, on a spacewalk.
Oh, can I be in this example?
Okay, so you're in space holding a toothbrush.
A toothbrush?
Yeah,
Is it mine or did I find it in space?
it's yours. You took it for this experiment.
Oh, okay.
Now, as an astronaut in space, you're attached to the spacecraft by a strong cord. But if you let go of the toothbrush, do you know what would happen?
It would just stay there.
That's right, because an object at rest wants to stay at rest. And what would happen if you gave it a little push?
It would start moving and just keep on going forever and ever and ever.
You mean until it slowed down? Right?
No, I mean it would just keep going for like 1 trillion miles and more.
That's a good toothbrush. I should have kept it.
You see, there's nothing in outer space to slow it down. There's no air, no resistance, no friction.
What do you mean?
Friction comes from things rubbing against each other, like the skateboard. The reason it slows down and stops is because the wheels are rubbing against the floor, creating friction.
Even the air in here slows the skateboard.
All right, so ignoring friction, in the absence of any other external force, objects will retain their initial motion. Object moving is going to keep on moving straight down at a constant speed forever and ever and ever.